Hey, what's up, people? We're back. Alright. Title of this one's gonna be well, basically the same thing, eh? System logic. So we'll just leave it as that for now, and then we can change it when we finish, I guess. Alright, so we're gonna do another hour. So let's go ahead and set the timer. Our extensions are good because we set those earlier. Alright, 67 minutes is set. Oops. Okay, yeah, you can hear. Alright, audio's working. Good. Great. Okay. Alright, so we did a lot of brainstorming last session. We got things mostly figured out, I think, with the like how this is all going to work with the save system. And I need to figure out what exactly I should do next. Well, I guess we'll just finish the custom append list stuff because it does need to be done. Yeah, it does need to be done. It does need to be finished. It will be used. So yeah, let's go ahead and do that. That seems the most sensible thing to do, is finish what we started. Instead of like, technically, you know, we should have done the outer section first in client, that, you know, this section for apply, but whatever. It's not a big deal. We're gonna instead pick up on save logic, custom append list save function. Okay, so let's see. Well, we'll put this at the top because that's the thing we're working on first. So let's bring this all the way to the top. So let's move this stuff that's not highest protocol, people dumps. That's not a pressing issue. I only want to put pressing issues. Damn, all this is under. Okay, we actually already have this. Listen, so I don't even need to. I just realized I have that. Damn, look at all this things to do. Buddy. So here's what we're gonna do. We're gonna copy all this, and we can actually do this more quickly, I think, by minimizing it. We'll do that, and this will copy everything. And then we C. Now we're gonna go to pressing issues, and we should just be able to paste this in. All this stuff. know if it saves the fact that I collapsed this stuff, or if it like, what is the keybind? Actually, you know what? I know there's a keybind for this. Let me look it up. Python VS Code collapse all. To collapse all code blocks, Control Shift P. I don't. Oh, then search for fold all and select to collapse all code blocks. Control K, then Control 0. So we do Control K, Control 0. There we go. Beautiful. Control K. Let me put that in my notes so I remember that's what it is. Control plus K and Control 0. You say Control dash K plus Control 0 equals collapse all blocks. Cool. That's much better. And now in current issues we are going to, because current issues is now has all been a custom append list, append pop clear save system function. Yeah, so now we can go to this. So now everything should be gone from current issues. So if we do current issues, yeah, current issues is empty now. And that's what we want. Because current issues is what we're working on. And what we're going to put there is we're going to put we'll just do one at a time here. So let's do this one first. Custom append list append pop clear save system create function which handles saving data for various method calls in custom append list. Well, we actually did this already. Prefix messaging. Okay, so we did this, so we can get rid of that one. But we need to finish it. It needs to be finished. Copy lines 139 to paste and save registration. Okay, we did that. Ensure broadest scope. Apply section save logic. Stable versus unstable database states. Determine actual code location for saving states. Card limit save issue. Concerning how database function. Test append save logic to script. Okay. Card limit save issue. Decide to have a checkpoint at the beginning of and end of append. If it doesn't make a point, check where we virtual system logic. The other one checking the file up. Okay. Yeah. Okay, so the current issue that we want to work on would be finish, save logic. Just say custom append list save function. Associated logic. Finish how/where this function is called in the various custom append list methods. Alright, and that is indeed where we need to be. So let's go ahead and do that. Determining where exactly inside of the associated methods the function call should occur. Where exactly inside the function call should occur. Should it occur at the end after the visual is completed? Add this function call with the proper args into pop and clear. Okay, so as concerning where the function should be called at, which saves the data, well, since it doesn't actually, like, quote-unquote matter unless we hit that end checkpoint, technically it doesn't matter, right? Like, if it happens at the beginning or if it happens at the end, we're not ever going to use this data unless it actually finished going through the section that called it. So I don't really think that it matters where this happens. But I mean, for organizational purposes and just for, like, you know, common sense purposes, I think it does make sense to have it located after it is actually, like, happened. But since this really pertains to not the XY coordinates and stuff, I think it's fine to just leave it here at the beginning. So we're going to leave it here at the beginning. Yeah, I think we will, because the movement function gets called within this function, and that will constantly update the data to the database associated with each card as far as the XY values and stuff. So and unless it makes it all the way through this, append, and then gets to the next section, it's not gonna matter anyway. But if we do add a level of precision on top of what we have, where we would consider this checkpoint to be a stable checkpoint to revert to, then I suppose it seems like in that case we would want it to happen after the physical, the visuals were done. But I don't know if, like, this depends it depends on, like, let's say we do leave it at the beginning. Card movement happens, then it crashes. Card movement, it crashes during card movement. Well, as long as we had it set to where it re-entered into card movement or whatever and finished that properly, then it's okay to have it at the beginning. So technically, it doesn't really matter as long as we are handling the logic, the reconnect logic properly. Why is it so hard to like imagine? I don't know. It's just hard to think about. So we save from P1 to melds at the beginning, right here. Then it actually starts to move from P1 to melds, okay? Now, that's fine. The issue is whenever we reconnect, if the card is considered in the meld already, then it would start, you know, to basically like assume that it had already been moved, but it hadn't been. But as long as we had the proper re-entry, reconnect logic, whenever it reconnected, it would just restart. It would just restart the card movement process. So just in the same way, it's basically the same exact problem that we worked through with this function being called in the context of append. Basically like the apply section calling append, and us having save checkpoints at the beginning and end of the apply section versus the internal save sections at the beginning and the end of append. It's like the same thing. We have checkpoints at the beginning and end of append, and we would have beginning and ending checkpoints in the end of inside a card movement. So whenever the card itself went to move, if that got interrupted, you know, in the middle of the process, it would revert back. It would revert back to that location, the starting location, and it would just remove it. So, like in theory, just talking that out in the simple terms like that, that seems fine. It seems like it would work. See if I can find where this actually is. Okay, so yeah, this is where the actual card movement happens. So we would just have, you know, a checkpoint like before this and then after it or whatever. And if it didn't I don't know. This is a little bit of a different scenario. I'm trying to think. I feel like we have this. In the case of appending a meld, it would begin to move each card in the meld. Let's say it crashed, you know, in the middle of one card, you know, in the middle of the meld. Would we restart the entire meld, or would we restart just that card? Well, that depends on how hard it would be to implement a reconnecting logic that would handle that. You know what I mean? So I'm gonna save. I'm not gonna think too much on that, because that's just that's a level of precision I don't really need right now, and I just don't really feel like thinking about it. I would rather just focus on the section. I don't think the location of this save function actually matters regarding relating to that. I think it's fine to say that the card exists in the meld before it has been moved to the meld, as long as we make sure that it's not considered moved to the meld when it hasn't been. So these are two separate questions. So we're gonna just leave that there at the beginning of the function. It's no big deal. It's fine to be there. So that's where we're gonna call that. Finally made a decision on that. Okay, so let's go over to save logic and determine where exactly inside the associated methods. Shouldn't it occur at the end? Yeah, I mean, it doesn't really matter, is what I'm getting at. It doesn't really matter. It's either or. So we'll just leave it at the beginning. We can come back to that later if we want to get that precise. Now we need to add this function call with the proper args into pop and clear. And we need to determine where inside each one of these methods it should occur. So let's go over to custom append list. We're going to go to pop. So we have pop, self, item, change from dirt check equals false. Item here is going to be an integer. I'll just put a little note here. Remember that item type will always be integer since it's an index. Yeah. Alright. And oh, we already added this? Oh, we already added it. Custom event list, passing in p group, card group name, and then the item. Method string, card group name, and then item. Method string, card group name, and then item. And self card group name should suffice. Item is going to be the index. That's fine. When it calls when it passes an item as an index, it's going to go down to elif method string is equal to p, and then it's going to do card group data list pop, and it's going to pop that index from the reflected card group. That should work. So parameters method string card group name item equals none. Alright. Easy. Okay. Now clear. Did we add it here? Okay, we did. And we said if card group name is in deck or discard pile. Oh wait, I'm sorry. No, we didn't. Okay, yeah, we did not put it in there. So let's go ahead and add it. We'll say visual. No, it's not visual data. We're gonna say custom append list save function, and we have to pass in method string which would be C. Card group name would be self card group name, and then item is nothing. It's going to default to none. So yeah, custom append list save function, passing in C for the method string and the self card group name as the card group name argument. That should be perfect. Actually, I don't think there's anything wrong with that. Where we at? Alright, so that's done. We have taken care of all three functions: clear, pop, and append. That's done. Alright, so now we can get rid of that. And we reviewed it. It was really easy, actually. Okay, so that's done. That was easy. So finish custom append list save function to logic, finish however this is called in the various custom list methods. Alright, so we can get rid of that as a current issue and pick our next problem. We'll paste this in here. It's going to say finished custom append list save function associated logic. Where this function is called in the various custom append list pi methods. Yep, and then we reviewed it. Everything looks good. All right, so that puts us at 555. Now we're gonna do the next thing. Which is gonna be, I don't know, let's see. Ensure broadest scope for first save system logic. Apply section save logic. Stable versus unstable database states. I guess since the next associated section, like and logically following what we just did, we would add in code here to handle yeah, so we would add that logic in. And what I really should do is I should copy this, basically. I feel like I should copy this entire section because we have this refactored structure and then the non-refactored. And that's fine. I think it's okay, yeah, to leave this commented out section for like a quick way to compare how it was previously without having to like switch branches and stuff. I mean, we could put it in its own file called client old. That makes sense, right? We could do that. Because I don't want to have to switch branches just to compare to the old version, and like, which is the last stable version. Yeah, I think that's how I would rather do this, instead of having it in the same file commented out. So what we're going to do is we'll create a new file, and it's going to be called client old, and we're just going to put a note here at the top which says, well, what's the blue? How do you do the blue question mark? We'll say file info created 3/26/25. Purpose was to to preserve the old / stable form of this file prior to the save system refactor for easy comparison against the refactored code. Alright, and now we can go over to client. Copy this entire thing. And we can just backspace out of it, get rid of that, all the way to the top here, and find that part, start refactored structure, get rid of that. Now we can go over to client old and paste that in. All the way to the top, uncomment that out. There we go. So this is how it existed previously, and now this is how we'll just reference it. We'll compare it side by side, basically. So I'll add this as something that I did just in case I need to come back and figure that out. Created client old pi, moving the unrefactored form of the client pi file, last stable state. I think it was the last stable state. To this file for easy comparison to new refactored code in client's file. Okay. Yep. I do want to remove these notes. We did already do that. Yeah. Wait, why did this? Oh, I see. Okay, we did it. Okay, next. I think we should do apply section save logic. Intrude into section file concerning proper save logic. In client pies apply section. True. So let's go ahead and move that up to current issue. Right. Let's go over here to the section. Okay, I see. I'm like, wait, where's the code at? It's because we were transferring it into this refactored version. So we have to insert this, basically all of this, if name equal name, this entire old version of the file. We have to insert it into the proper section here. Let's see, we have the try acceptance will remain, counter game crashing errors or soft disconnect. And then we have while true, which is the main while loop. Okay, I see. So we had this section has already been refactored. Okay, so we have the main while loop. So this is stuff that would happen regardless. But then we have let's see if I can find, where does this start at? Of accept, try, while true. Okay, yeah, right. So it exists in the context of the outer while loop. So this is the outer while loop, and then we try to begin the main while loop. Okay, gotcha. Now this is making sense. So we can uncomment this out. And then I think we'll add the client code. This while true corresponds to this while true, I believe. So I would actually like this. I guess we could put in the context of the try, like that. So yeah, let's start the main while loop, try while true. That's good. Okay. Should we have this comment there? The main game while loop which runs after initial data exchange, priority assignment, etc. until game termination. So yeah, I feel like we should just straight up copy this entire thing. I believe we should. So wait, is this try while accept? Where is this accept? What is it connected to? So that was the while indent. And then we have, okay, so the accept is one step up. So that's the outer accept. So we need to go from here all the way up to the beginning of this while. All the way up here. that. And we're going to replace from while true. But we do want to add in this client soft disconnect. So let's do like this. Paste it in right here. And now this indentation is all jacked up. We have to fix it. This needs to be indented. And then indented again. There we go. Now back to the top. Start main while loop, and then we'll put this line right here. This can go away. This is main while loop, just in case we don't see that big highlighted comment above it. So this is while true, it does all this stuff. The end of the main while loop. And we have our outer except. Okay, so I think we successfully we did that the right way, I believe. Now let's go to that apply section. Oh, and you know what? We deleted those comments. So here's what we can do. We go back to client old. Let's undo. Copy this comment. And this is at if length of so as soon as you can do this is equal to 0. Let's find this section. Start application section. Okay, here we go. This is where it should be. Yep. Paste that in. And of course, it fudged up the indentation. I don't know why it messed it up that bad. Okay. There we go. Now let's get that other set. Copy that. Now we can redo these changes to revert it back to its prior state. Paste that in. And it messed up the indentation, of course. Now we can fix the comment. Alright, there we go. Now we're good to go. Now we have all of this code from the old client inside of the new client file, but I think we need to So this has not been refactored, and this includes all of the. Sorry, it's not right. Okay, while true start of the main while loop. So from here down, that has not been refactored. So let's note that. We'll put. Start of unrefactored section sections. Moving all the way down to the bottom. Right here, we'll put this, which is going to say the end of the unrefactored section. So everything else has been refactored except for that. So let's put a bookmark here. So now we can always go to our bookmark instead of having to scroll through this file. And we're also going to put a bookmark at the apply section. So we don't have to scroll to it like this, right here. Okay, so we got another. So now we can quickly jump to our sections that we're working on. And I gotta use the restroom real quick. I'll be right back. And then we'll try to knock this out. So we have save system determined that we would need a checkpoint here. Checkpoint will have an associated checkpoint at the end of this iteration. If it doesn't make it to the end checkpoint, data will be reverted back to this point in time. One thing to note here is that all checkpoints that take place within this context should be discarded unless we reach the final checkpoint in this iteration. Alright, so let's go ahead and add this checkpoint. And what we're probably going to do is we're probably going to end up adding this, creating a function. I don't know though, because we would have to pass all of this stuff to the function. We'd have to pass in like the dir string var, because we're gonna want to save. Well, hold up. What exactly would we be saving here? Well, at this point, we would want to save. We would want to save all of the data that has already been written to the database. Like, would this be considered a stable checkpoint? Would this be considered a stable checkpoint? I mean, I would say yeah, we'd want to save the apply list. Exactly how we would do this. So we have iteration through the apply list, and I guess yeah, so the way that we would do this, I'm figuring it out here, is we would save the state of the apply list as it stands in the iteration process. So if this is the first iteration through the for loop, then the apply list that we would want to save would consist of all elements in the apply list, because if we didn't make it to the final checkpoint in this iteration, then when we reconnected, we would reconnect back to this section, and we would begin iterating through the tuples in the apply list, just like we are doing, right here, since we didn't successfully make it through any of the iterations. But in the case that we did make it through, 1, 2, however many X iterations, every time we do that, we would save the shortened version of the apply list. So let's say this is the second iteration through this for loop. That means we've successfully checkpointed we've successfully completed the first iteration, and we reached a new stable save point. After we have reached that new stable save point, that means that's a point to which we would restore the game to upon a reconnect. So when we reconnected, in the case of the second iteration, let's say we DC'd in the middle of the second iteration. When we reconnect, we're not going to reiterate including the first element, because that's already done, because that data's been saved. Therefore, when we reconnect, it's going to be applied. So we would want to start at the second element, continuing on. So that's what we have to do first, is we want to save the apply list in the proper context of however many elements are left in it. So from the current index onward in the list. So let's go ahead and do that. We'll say cursor dot execute, and we should have access to cursor, right? Almost I'm 99% sure we should. And then we're gonna say, wait, we have a, don't we have a function for this? We do. Do we not? Execute, select. Where is it? Here it is. Visual data save function. So that takes the object name and then data, and it will do an upsert. And that is indeed what we would want to do, right? Yeah. So we'll call this function, passing in the proper args. Now the name of this is probably going to need to be changed. The name of this function, because it's not really only for visual data save for visual data, it's for non-visual data as well. It's honestly, it's just an upsert function. That's really all it is. So we could just change this from visual data save function to upsert, but I'm not going to do that right now. We'll put visual data save function to upsert data save function. This doesn't only handle visual data and is more specifically an upsert function. Therefore, needs to be renamed to upsert data save function instead. But when we do this, well, I don't know. We might not even need, like, we might not need that other save function, but that kind of will fall into place. Like once we get to that task, I'll see that. So we can just leave it as it is for now, and we'll go to finish this implementation into client. So we have visual data save function taking an object name. So the object name here is going to be the, okay, it's going to be the, well, we just say apply list, right? Because there's only one apply list per client, so we can just call it apply list, just straight up. We can just say apply list. That's the object name, and then the data will be, well, we have to wait. Doesn't it internally? It internally serializes it, right? Serialized data equals pickle dump. So must serialize the data. Wait a second. I see a bug here. It's supposed to be serialized data. Whoops. This should be. So you take in data, then you serialize the data via pickle dumps data. But when you pass it to the database, you want it to be serialized data. Yeah, not data. Okay, cool. Now that's, so it handles upsert internally. I mean, serialization internally. So all we have to do is pass in the apply list, but we don't want to pass in the entire apply list. We want to pass in from we want to pass in from the index onward, but we need first a num. We just call it index num, and it'll start at 0, and we'll say for tracking index number of below for loop used for creating truncated list of apply lists for proper visual data save function arg passing. We'll call it data arg. Put here that we saves a truncated version of the apply list including only the current item onward, or current elements. Since if we already completed full iteration of an element, it has already saved to the database, and that should be sufficient. So save the truncated version of the apply list including only the and I'll just add ensures upon reconnect we don't double apply data. Apply data from this list. So we're going to say apply list at index. So how do we do this? Oh yeah, we use the num. So we'd say apply this at, and then we'll start. So we do a sliced copy, and we say apply list at index index num to, and then just leave it like that, right? Isn't that how you so if we did apply list 0 colon and then just blank, that goes through our index apply list at index 1 colon, that would go from the second element to the end, like including the final element, right? Pretty sure that's how it works. Let me just verify this. So we'll go to test reminders. This is one of those silly things that I'm like 99% sure, but I just forget sometimes. So if we have a list which is 1, 2, 3, 4, and then we say x equals L from index 1 onward, and then we print x, this will give us 2, 3, and 4. Yeah. Gotcha. I already knew that. I just I always tested myself. So right here, close this one, and yeah. So that's correct. Apply list at index num onward. So for the first iteration, it will save everything from the apply list. On the second iteration, it will save from the second element, aka index 1 onward, and so on and so forth. Once it gets to the third element, it would be index num 2 onward. And yeah. So whenever we reconnect, the apply list that we load in for application will be we'll have all the elements which already we have completed a successful iteration from that list, so we don't double apply the data. So now we need to add in the increment for index num. So let's go down here to the end of this for loop. plus equals, that's not right, index num plus equals 1. There we go. So yeah, so index num starts at 0, and then we iterate through the apply list. We then save the apply list under the namespace apply list, since we don't need a p1 or p2 prefix as a string, and then we say the data is apply list sliced copy starting at the index num, which would range from 0 to whatever length it is. So from the first iteration it would be 0, the first element, all the way to the last element, aka index 0 onward, and then secondly, whenever it hit end of this iteration, index num would be incremented plus equals 1. Now index num would be equal to 1, so then this would be apply list at index 1 onward, which includes the second to the last. Yeah, so that's good to go. All this looks good. I can give it my double stamp of approval. Save a truncated version of the apply list, including only the current element onward in the list. Since we already completed full iteration of an element, it has been saved to the database. Ensures upon reconnect we don't double apply data from this list. There you go. Cool. Yeah, so what else do we need to do? So this would be considered a stable save state, right? I mean, I think it is. Let me think about this. So save function. Yeah, I would say at this point in time, well, hold up. We're saving at the beginning of the iteration, the apply list. So for the first iteration through this for loop, I'm trying to think, do we have a stable save state prior to this or after this? So if we're at the beginning of this iteration, that means it hasn't completed. And that means it's not stable after this. Like, this, we would not want to reconnect and load in the apply list at index num unless we had yeah, we wouldn't want to. It's not stable after it, because if we began iteration through this and then got disconnected, like just right here on this line, but had saved this, that's not stable, because then if we well, actually it would be, right? Because then when we reconnected, it just wouldn't start us off at the one before. It would start us off at this one. Does that make sense, right? Yeah, it would start us off at, let's say this is element number 2, aka index 1. If we started this iteration at index 1 and then got disconnected right here, since it didn't reach the end of this iteration, it would revert back it would revert back to we would want it to revert back to the beginning of this iteration, right? Yeah. So that does mean we would want this data to be saved like as a stable state, right? Because that's what we reload from. When we reconnect, we reload from the last stable. And let's just say we don't. So we have two scenarios. The scenario one is we don't save this data, like, let's just say scenario one, if we don't save this as a stable save state, then when we reconnect, we would reconnect at the previous index, or yeah, at whichever the previous iteration was. So if it was the third iteration and we hit this point, we save this. We successfully completed iterations 1 and 2, so those could be reapplied. All the data's been done. Like, everything's safe with that. It's completely stable. We can just load that data in from the database when we reconnect. And now we're gonna start. We want to start on the third index. That means we would have to save that data we'd have to save it to the stable save state. But I'm not sure that this should be in this location. I'm not sure that we should have this function right here save the apply list right here. I think well, no, that's fine, right? Because but that means we would be double, like, at the end, or we could do it at the beginning. It doesn't really matter, does it? I was gonna say, because that would disrupt the fact that we're saving the stable state at a certain point in this iteration. We're saving it either at the beginning or we're saving it at the end. Does it matter? I don't think it does. If we did it at the beginning, as long as we did it after this line of saving the apply list at index none, if we then saved to the stable, then that means when we reconnected, we would rerun this section in iteration through the apply list, and the apply list would consist of all the data that has yet to successfully complete an iteration through. So yeah, I would say we would create the next stable save state at the beginning of the iteration, which is also the end of the previous iteration. So if it was the end of the first one, after that, we're like, okay, we successfully saved all that data. I mean, we successfully completed that operation. Therefore, now let us save the new apply list, which is truncated, and then, just in case we disconnect, we're going to back this up as a stable save point. So when we're going through this iteration and we disconnect, whenever we reconnect, since we didn't make it to that next checkpoint, it would revert us back to this beginning of the iteration, and it would start at the correct element, excluding that first element that had already been successfully iterated through and subsequently saved. Yeah, so I think we'll put a note here, and I'll put 32625 save system. Quite certain we can have this stable save state creation at this point, since we're certain we can have this stable save state creation at this point, since we either are on the first iteration or have just completed a full iteration. Review this decision a bit further, but I'm pretty certain this is a solid idea. The only concern would be that we might want to lock the process just in case it crashed after the iteration. But, well, no, because this is the checkpoint. We're not going to have one. Yeah, we're not going to have another at the end. Because, like, the beginning is also the end. Does that make sense? The beginning is the end of the last iteration. So, this is a stable section. Yeah, so this is where we'd want it. So we'll say add in stable save state at this point. Let's put this note right there. I don't think we need to review it any further. I guess I will next time, just in case when I I can always be wrong. Add in save state at this point. So we'll say we'll create a function probably that does this, and we'd have to import it. So it would be called, we'll just say stable save state creation function. And it needs to be created. Yeah, so that's where we're going to stop. Put a date here. Create this function. Create above function. Let's put next. I think I added a little bit too much notes there, but it's fine. We can fix that. All right, so this was line 612 in client pi, so let's go over here and actually let's copy this and paste that in. Stopped at line number 612 in client pi, and then we did 601 to 650. Continued adding in save system logic into apply section. Directory, we get branch, we're on the right branch, get add to add everything, get commit -m, paste in that devlog message which says save system client pi, save system logic. Yeah, and that's right. Cool. Yeah, that's fine. I was going to say we could be more specific on the fact that we added in that old client code into the new client code, but like just straight up, it doesn't matter. So we have git push, push to the remote repository, so we're good to go. We're done. We just have to back up the local. So let's go into Canasta, copy that one, backup, delete it. Paste in the new one. And we don't have to rename the folder because we already did a session today, so it's already been renamed. But the time is right, 6:52. We go back out, and the folder's already been renamed, so we're good to go. All right, good progress. Not terrible, so we're getting there. Save system is, I would say, it's about. Not counting like the reconnect logic. The reconnect logic's not going to be very easy, so that's like a whole task in and of itself. But I would say the overall save system logic and just like code and all that is about, I would say, about 50% maybe. About 50%. Maybe not quite 50%. Maybe 40%, 35%. But we're getting closer, and I can actually see, like, I understand the system pretty good now, and I think it'll work, so there's not really going to be a lot more brainstorming and outlining. It's more going to be adding in the actual code. So we're using a client file, client files main while we like the send, receive, apply, filter sections, and then so I would say probably another maybe 10 hours of work on that, and then we'll probably test all that and make sure it works, and then we'll have to add in the reconnect logic. That's kind of like a whole separate thing. So